Alright, y'all, today we are going to be talking about what are complex numbers and how do we write them in standard form. We're going to be looking at something called standard form. Some vocabulary that I want you to remember or recall includes square root, real versus or and imaginary numbers, complex numbers, standard form, and absolute value. I don't think we're going to be using absolute value, so just ignore that. We'll just go with it. Alright, so let's take a look and look at three separate equations right here. And notice that it says, what is the solution? Or, aka, what is the answer? Alright, let's take a look at the first one. Notice that your variable is x, right? So x plus 2 is equal to 10. Well, how will you solve this for x? Well, that's easy. You're just going to subtract 2 from both sides. So you get x is equal to 10 minus 2, you get 8. And so 8 is my solution. 8, that sounds like a real answer to me, right? You can count to the number 8. Alright, number 2, let's say 2x plus 3 is equal to 4. To solve this for x, you would subtract 3 from both sides. You get 2x is equal to 4 minus 3 is 1. Then divide by 2 on both sides, so you get x is equal to a half. Or if you want to write that as a decimal, if you have half a dollar, that's the same thing as 50 cents. Alright, well that sounds like a real number to me. Alright, and then let's take a look at number 3. Alright, for number 3, I'm going to arrow down. It says x squared minus 20 is equal to 0. Well, to solve this for x, I'm going to add 20 to both sides. And so that will give me x squared is equal to 20. To get rid of a square, you have to take the square root. And so I'm going to get x is equal to the square root of 20. And in reality, I should put plus or minus, because whenever you take the square root of a real number, it could be plus or minus. Alright, so that square root of 20 looks like I can simplify it, because if I remember my square chart, like, let's look at my numbers, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I look at my square chart, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. If I look at my square chart, I notice that 4 right here is a multiple of 20. 4 times 5 multiply to give me 20. And 4 has a square root. The square root of 4 is 2. So I could simplify this, instead of writing plus or minus the square root of 20, I could write this as plus or minus 2 the square root of 5. And so then that would be my solution, or my answer. Again, all three of these are real answers. They are real numbers. 8 is a real number. 1/2 is a real number. And even though 2 squared root of 5 looks horrible, that is technically a real number. In fact, it is a number that is between 4 and 5. It's some number between 4 and 5. I can't give you the exact one because I don't have a calculator, but it is a real number. Now, let me throw one more equation at you right quick. And let's talk about why this one is not so easy to solve. If I try and solve this for x right here, this is x squared plus 1 is equal to 0. If I subtract 1 from both sides, that gives me x squared is equal to negative 1. If I take the square root of that, I would get the square root of negative 1. Well, I have a problem. I know the square root of 1 is 1, but I have no idea what the square root of a negative 1 is. In fact, can I get a square root of a negative 1? Because if I multiply two numbers, a positive times a positive is a positive, and a negative times a negative is a positive. How will I get the square root of negative 1? Or how will I get negative 1 by multiplying two numbers together? Well, that problem was discussed by a certain guy about 400 years ago. His name was René Descartes, and he proposed that we come up with a symbol to represent the square root of negative 1. And his proposal was, well, that doesn't seem like a real number, so I'm going to call it an imaginary number. And so he used the letter I to represent an imaginary or non-real number. And so whenever you see the square root of negative 1, we're going to say that that is I. Now what's interesting is that if you have the square root of negative 1 as I, if you were to square both sides, remember the square and the square root cancel each other out, so that would just give me negative 1, and then I squared would just be I squared. That gives me another rule that I squared is equal to negative 1. So two very important rules that you need to know is that I is equal to the square root of negative 1 and I squared is equal to negative 1. Very, very, very two important rules, things to remember. Alright, so let's take a look at two practice problems right quick. Alright, take a look at this first one. It's the square root of negative 12. Again, that negative sign underneath the square root lets me know that I am going to have an imaginary unit, so I'm going to take out the I, but I can simplify 12. 12 is the same thing as 4 times 3, and then the square root of 4 is 2, so that would give me 2I square root of 3. Alright, for the second one, again, those negative square roots let me know I'm going to take out an I, so that gives me I root 6 times I root 10. Alright, I'm going to multiply these together, and so when I multiply these, I'm going to do I times I, which is I squared, and then the square root of 6 times 10, which is 60. So that gives me I squared square root of 60. Well, if you remember, I is equal to the square root of negative 1. I squared is equal to negative 1. So that means that this I squared is really negative 1 root 60. And then I think I can break 60 down. In fact, 60, I know that 60 is 10 times 6, but the problem is 10 doesn't have a square root and 6 doesn't have a square root. So I've got to come up with two other numbers. So what about 4 and 15? 4 times 15 is 60, and the square root of 4 is 2, so I'm going to have negative 1 times 2, so that would be negative 2 root 15, and that would be my simplified answer for that problem. Alright, one final topic that I'm going to talk about, and I should have been more specific. So anytime we have an imaginary I, that's where we get into the realm of complex numbers. So I'm actually going to go back. Oh, shoot. I'm going to go back. I'll have to go through and then go back to this slide right here. Let me go back one more time. Bear with me. This slide right here represents all the numbers that we know of. So complex numbers covers everything. They include real numbers, like 2, 3, 4, 5, 6, 0, negative 1, negative 2, negative 3, 1/2, 3/4, 1/5. Irrational numbers like pi, like 3.14159, numbers that keep on going. All of those fall in the category of real numbers. Those are real numbers. Purely imaginary numbers are whenever you have, I, like 3i, or the square root of negative 4. Those are purely imaginary numbers because the square root of negative 4 is the same thing as 2i. But when you talk about everything, a complex number is that combination of real plus imaginary. So a complex number is written in the form a plus bi. So, like for example, 2 plus 3i, this is a complex number, not because it looks difficult, but just because it has a real part. The real part is the 2, and an imaginary part, in this case, is the 3. So that's what we consider a complex number. Alright, the last thing I wanted to talk about was simplifying powers of I, and what I want you to remember is the phrase I won, I won. So I won, and make sure you put the negatives in the middle. And what this means is that if you have I to the first power, that's just I. If you have I to the second power, that's negative 1. If you have I to the third power, that's negative I. And if you have I to the fourth power, that's positive 1. And you can actually keep on going and do like I to the fifth, I to the sixth, I to the seventh. But I'm going to show you a little bit of a trick of how we will actually solve that rather quickly. So, for example, let's say that I wanted you to simplify I to the 12th power. Well, what you're going to do is you're going to take that exponent and you're going to divide it by 4. Well, 4 goes into 12 3 times, and thankfully doesn't leave a remainder, no remainder. So remember that chart, I1, I1, two negatives in the middle. If you have a remainder of 1, that means your answer is going to be I. If you have a remainder of 2, it's negative 1. If you have a remainder of 3, it's negative I. And if you have a remainder of 0, your answer is just 1. So I to the 12th simplifies to just be 1. And so that's my answer. I to the 12th is 1. And you can actually work that out if you wanted to. So like if you actually times out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you wrote down all 12 of those, remember I squared is negative 1. So every time I have I squared, that's negative 1. So each one of those is negative 1. And then if I multiply this, negative times negative is positive, negative times negative is positive, negative times positive, 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 all that would be times 1. But instead of writing all that out each time, if you'll just remember this chart, it makes it easier. So look at the second one, 39. So again, divide it by 4. Well, 4 goes into 39. 9 times 4 is 36, and it leaves a remainder of 3. So look at my chart. So my answer is going to be negative I. Alright, the last one, 10, so divide it by 4. 4 goes into 10 2 times, and it leaves a remainder of 2. Look at my chart. So this is going to just be negative 1. And then that is it, guys. That's it for today. Try some of the practice problems at home, and then we'll learn something else tomorrow.